Okay, I am Liesel Altengeest and I will be presenting this video on your time value of money assignment for your LFBE 5800 module. To start off, it's necessary to explain the difference between nominal percentage and your effective percentage. Now, the other name for the nominal percentage is basically the annual percentage rate, or APR. So on a different calculator, you might see the APR button and not the nominal percentage button, but those are exactly the same things. Now, basically what the nominal or APR tells you is what is the quoted rate, the rate that is quoted to you by financial institutions. But with that rate, you will find the words compounded by. So a company might, or financial institution might, quote you a rate of 6% interest on a savings plan, compounded monthly. So you get that compounded monthly part at the end of that interest rate. And that tells you that if that compounding period is more than yearly or annually, then you know that your nominal rate is not the real rate, or the quoted rate that they are quoting you is not the real rate that you are paying or receiving. So because your interest is calculated more than once during that period. Okay, so the nominal rate is the quoted rate. Financial institutions have to, by law, quote you the nominal rate, and then they will provide you with that compounding periods part at the end. And your effective annual rate is the one that indicates what you are really paying on an annual basis or receiving on an annual basis. So the effective annual rate is also called the EAR or the EFF, and therefore you need to know the difference between the two in order to when you calculate some of your questions. Okay, so let's look at an example on where it would be important to be able to use your effective rate and your nominal rate. Now you can see this example says that Jonah has a choice between two saving plans. Absa will pay an interest rate of 6% compounded semi-annually, and FNB will pay an interest rate of 5.8% compounded daily. So those are the quoted rates. That 6% compounded semi-annually is the quoted rate by Absa, and the FNB quoted rate or nominal rate is that 5.8% compounded daily. So what is important here is to notice that you can't compare these two interest rates with each other because it's different time periods. So you have to convert both of them into, or calculate their EAR or effective rates in order to be able to compare them with each other. So I'm going to show you on the next slides how we would then compare them.
Okay, so let's do the first calculation where we have to work out the 6% savings plan compounded semi-annually. The first part is obviously to go and indicate to your calculator what is the time periods that we are talking about, or the compounding period. So for that semi-annually one, for Absa, it will be 2 second function and per year. So if you want to test that, it's just the second function and then clear all, and it will flash on the screen 2 per year. So now you know the calculator is going to work it out on a semi-annual basis. Now remember, the values that was given to you is actually the nominal values. So you're going to put in 6%, second function and nominal, and you're going to ask your calculator for the effective percentage, which is here, but you can see it's a second function, so you press second function, effective, and you can see that for that Absa savings plan you are in effect really earning 6.09%. Okay, so now we want to do the one for FNB, and we have to change our compounding periods to 365 periods per year because it's compounded daily. Now you will see here that now if we just want to test again, 365 periods per year, and we're going to put in our nominal percentage, which is 5.8%, second function nominal. We're going to ask our calculator what was the effective rate in this case. Now you would think that because it's compounded daily, 5.8% would make that a much higher percentage, but you only get to 5.97%. So it's almost 6%, whereas you get with the Absa savings account, you get 6.09. So with savings accounts or investments, you will obviously choose the higher interest rate, which in this case would be the Absa savings account. Obviously, if it's a loan, you would choose the one with the lowest interest rate.
Okay, what is important when you approach a question is to first look at what they are saying in terms of the interest rate, and then to look at what type of payments are being made and also what the periods are relating to that payment. Now, if you look at the first example, you will see here that it says Insiki took out a loan with a value of 450,000 Rand at an interest rate of 8.5% for 8 years, which is payable in monthly installments. Now, what they are saying here is that they don't mention anything compounded, so then you assume that's annually. And therefore 8.5% is calculated annually, but that there is monthly installments. So that is an indication to you that you will have to do something with your calculation here to get them on the same time period. The next one you will see is Nulene invests an amount of 45,000 and will in addition invest 8,000 Rand annually. So she will make annual investments to the same investment fund at an interest rate of 7.5% compounded annually. So here you will see you don't have to do anything. Both of them are annually. So that is fine, and you can just calculate it as it is. Then the last one says Jack wants to start investing 400 Rand per month in the beginning into an investment that pays an effective rate of 12.3% per annum. So here, this calculation is the effective rate which indicates that this is the real rate, annual rate that he will be receiving. But you will see here that his payments are monthly. So we need to look at a way to convert his yearly rate, his real rate, into monthly rate in order to work out this specific calculation.
Okay, so the last example is the one where Jack wants to start investing 400 Rand per month into an investment that pays an effective rate. And that word effective is very, very important because it tells us what he is really earning per year. Now, you will see that the payments that he is going to make is 400 Rand per month, so it's monthly, whereas this is 12.3% per annum, indicating that this is the real rate. Okay, so we want to, in actual fact, get to the nominal rate in this case because we want to see what we want to change our calculator to 12 per year because that's the monthly payments that he makes. So we want to firstly see not what he's really earning, but really what he is earning on a nominal level. Now, firstly, what you would do is you're going to change your calculator to 12 per year because it is monthly payments. And you want to see what the nominal rate would be when it's compounded monthly because we're going to convert it into months because you can see the payments are being made in months. So I'm going to put in 12.3% second function and I'm giving the calculator the answer of the effective interest rate and I want to know what is the nominal rate and you can see it's 11.6, let's call it 11.66%. 11.66%. Okay, so now I have my nominal percentage rate. I know that I'm going to make 400 Rand payments every month for 7 years. So you can see here that my payments is going to be 400 negative, sorry, Jack's payments will be 400 negative payments at 11.66% interest rate for 7 years. And remember, second function in, that make it 84 months. And I want to know what will the future value of this specific investment be. And you can see it will be 52,082 Rand and 44 cents.
One of the most well-known annuity calculations in our daily lives is basically a calculation of either car loan or a home loan. Now, in terms of home loans, specifically because it's easier for us to understand, you can use your calculator to work out what would happen if you decide to increase or decrease your monthly payments. How would that affect your specific home loan and the balance, etc. You can also calculate your balance of your loan, and you can also calculate at a specific period in time what is your interest that you paid and what was the principal that you paid for that specific period. Now, I'm going to explain all of those three things. So if you get a question on anything like this is how you would approach the question.
Okay, let's look at this example where Lebo wants to increase her payments, her monthly payments, in order for her to pay off her loan quicker. Now, in this case, you can see firstly that the question states Lebo bought a home 10 years ago for 250,000 Rand with a 20-year home loan. So she's right smack in the middle of her home loan payments at an interest rate of 9% per annum. Now, the payments are made monthly in arrears. Now, that is very important because a home loan is obviously monthly. So you put in 12 second function per year, and in arrears, it means that it is made at the end of the period. So you have to change that begin. If you have a begin on the screen, change that to end. So it shouldn't say anything on the screen. Now it says Lebo wants to repay her entire home loan 5 years early. How will her monthly payment have to change in order for her to reach her goal? Now, with any home loan payment, your first step is to go and calculate the current or the payment, the monthly payment, and from when the home loan started. So it's 250,000 is what the bank gave her to buy a house at 9% interest. And remember, for 20 years, so 20, and you have to press second function per year. That means a total of 240 months payments she will have to make. And I'm asking the calculator to give me the payments, and she will have to make 2,249 Rand and 31 cents every month in order for her to be able to pay off her home loan within 20 years. Okay, so that is the first step. Now, the second, in this case, you want to know now at this point, right smack in the middle of her home loan. Remember, she's currently 10 years ago, she got this home loan. She's in the middle. She has 10 years left. And we want to know right at this moment, what is she still owing the bank? And you do that with your amortization calculations on your calculator. You will see it's here. It's a second function of the future value button. And the first step that you do is you put in what month you are looking for. Now, if we're in the middle, right in the middle, we are looking for month 120. Okay, so if you take the 10 years multiplied with 12 months, we want to see in month 120 how much what is the balance that she still has left. So you put 120 input, 120, and you press second function amort. Now it shows you that these are the periods that you've chosen, and you say equal. That's the principal that you paid in month 120. That's the interest that you paid in month 120. And lastly is your balance. So you can see here that she still owes on this specific loan. She still owes 177,564 Rand and 72 cents or 73 cents. Now that is what she currently owes. So that means if you now use this as your present value, you can go and work out, because you see there in the question that she wants to pay her home loan off 5 years early. That means that even though if she only pays 2,249 Rand and 31 cents every month, it's still going to take her 10 years to pay off her loan. Now, obviously, she wants to increase those monthly payments and make her and decrease her time to pay it off with 5 years. So I'm going to put put that in as my present value, 177,564 and 72 cents. That's my present value. And now 5 years early means that 5 years early means that she wants to only have 5 years left. So 5 second function n, meaning she still pays within 60 months and at 9% interest. Nothing changes there. And let's see how her payment will change. So her payment will increase from 2,249 rand and 31 cents to 3,685 rand and 95 cents. So if she increases it by that amount, or to that amount, then she will be able to pay her home loan off 5 years early. Let's look at another example on how to calculate the balance of a loan at any point during the loan. You will see I'm still using the example of Lebo, and it says Lebo bought a home 10 years ago with a 20-year home loan, blah blah blah, and then it says what was Lebo's balance on the loan after the 3rd year. So you do everything exactly the same. You go and calculate what is the monthly payment firstly, so that's 250,000 rand at 9% interest, and I know that my home loan is a 20-year home loan, or Lebo's home loan, second function n for 240 months, and I want to know what the payment is. So that's exactly the same as the previous slide, 2,249 rand and 31 cents. Now again, we want to know what was the balance on the loan after the 3rd year. So anytime you see the word balance or interest rate or principal, you know that you're going to have to go and calculate the amortization schedule of the specific loan. And I want to know the 3rd year. What was Lebo's balance on the loan after the 3rd year? So 3rd year tells me that 3 times 12 months has already passed, so that's 36. So my 36th month, what did my balance look like? So it's 36 input 36, second function amort, and that shows me what I've chosen, and I say equal. That was my principal that I paid, my interest, and this is what I currently, or Lebo currently owes on this loan. She owes 234,590, let's say 96 rand. So that is how you calculate the balance. Okay, the last part that I want to explain is basically how to calculate the interest or principal component that Lebo paid within a specific time period. Now you'll see we're still working with Lebo, but the last part of the question is stated a little bit differently. It says, what was the principal and interest component for her 19th year? So this is the year just before she finished her home loan, if she keeps paying the same amount, and she wants to know what was the interest component and the principal component that she paid within that year. So that means from the first month of that year until the end or the last month of that year. And like before, you just start with your same calculations or your same steps. 9% interest at 20 years, second function n, gives me 240 months, and my payment is still 2,249 rand and 31 cents. Now this becomes important in terms of how to calculate the number of periods, because we want to know from the beginning of year 19 until the end of year 19 what was the interest amount that she paid and what was the principal amount that she paid. So if you go and calculate the end of the 18th year, that's 18 times 12 gives you 216 months. Now that is the end of my 18th year. So that means my 217th would be the beginning of my 19th year. So 217 will be my first input, and then the end of year 19 would be 19 times 12. That would be 228. So those two values gives me my, if I put now second function amort, you will see it's 200, so my month 217 to 228, and that will give me my 19th year. So now I press the equal sign. You can see here that during that year, not that just months, during that year, she paid 23,500 and let's say 15 Rand towards the principal, the original 250,000 Rand, and she paid in interest 3,477 Rand in interest towards that loan. So you can see it's towards the end of the home loan, so the principal amount is much more than the interest amount. In the beginning of a loan specifically, you're going to pay more towards the interest because your total balance is higher, and towards the end of a home loan, you're going to pay less towards the interest and more towards the principal because the balance have decreased. You can see also if we press equal, she still only owes 25,721 Rand towards this loan.
The last thing that we're going to discuss is an increasing or growing annuity, because you are working with two different interest rates, so that could be confusing. Now, when you work with two different interest rates, one would be a growth rate and the other one would be the interest rate, you're going to use this specific formula, which is your resultant rate. So the interest rate that you earn, and you have an escalation rate or growth rate, and putting those two together gives you the resultant rate, the rate as a result of those two interest rates. And you can see it's 1 plus I is for the normal interest rate, and then 1 plus E, or divide that by 1 plus E, which is your escalation rate. And you take that calculation and you minus by 1 and multiply it with 100 in order to get the percentage. Okay, so when you calculate a normal increasing or growing annuity, it's easy because you just go and calculate your resultant rate. The problem comes in when you have to look at an example like this, where you start with where you want to go, your future goal, what you are starting with, and then it gives you the interest that you earn, but it doesn't give you the escalation rate. So the steps that you then follow is, firstly, you go and calculate the present value of that future amount that you need. Secondly, you will then go and calculate your resultant rate by taking that present value and taking that present value into account with your payments, yearly payments. And then lastly, you will go and calculate your escalation rate. Okay, so the question states that Jack King needs 60,000 Rand in 5 years' time. So we're going to work out that present value of that 60,000. So it's 60,000 future value for over 5 years at an interest rate of 10%, and you want to work out what the present value is. Now this works out to be 37,255 and 28 cents. So now I'm going to use that value as in the second step to calculate the resultant rate. So it's 37,255 and 28 cents. That is my present value. My 7,200, which is a negative because it's a payment that I'm going to make, and over 5 years, and I want to know what the interest rate is. Now you're going to see it works out to be negative 1.68. So just because it's negative, it doesn't mean that the actual return is negative. We're still going to put it into our formula as a positive value. So just note there, it's 1.68. Okay, so you can see from this last slide that we worked out that it is the escalation rate in this case will be equal to 1 plus the interest rate divided by 1 plus the resultant rate. Now this is the one that I was talking about in the previous slide, where you now will, instead of, you will ignore the negative sign in front of the negative, the 1.68, and you will still say 1 plus 0.016849. You will divide that into the 1.10 and still do your calculation, and that will mean your escalation rate works out to be 8.18%. Okay, so this is the end of this assignment help video. I hope you do really well in your assignment. Thank you.